Hello, very good morning to everybody. Welcome back to my video session again. We are going to continue from where we stopped previously. So we are going to continue with the same chapter, which is chapter 6b, acid-base and solubility equilibria, where in this section, we are going to discuss structure questions. So before I begin my lesson, if you like my video, please help me to click the like button. And if you want to receive further notification, do subscribe to my channel and click on the notification button to receive the latest information. So with the session, let's begin our lesson. We are going to continue with the structure questions, starting from question number 1. Ascorbic acid C6H8O6 is a weak monoprotic acid, which is commonly present in apple juice. So explain what is meant by the term weak monoprotic acid. So weak monoprotic acids are acids which dissociate partially to form a single hydrogen ion from each mole of the acids. So in here, there are two keywords that you have to take notes in here. Number 1 is weak acid. Another one is monoprotic acid. So you have to define both terms in here correctly. So you must include dissociate partially, form single hydrogen ions. Okay, so that is for question 1A. And then 1B, in an experiment that used apple juice as sample, it was found that 25 centimeter cube of apple juice contained ascorbic acid at unknown concentration required 22.50 centimeter cube or 0.2 potassium hydroxide for complete neutralizations. Number 1, write an ionic equation for the neutralization. So in here you must have H plus OH minus give H2O. Then number 2, calculate the concentration of the ascorbic acid that is used in this reaction. So in here you have to use M1B1 equals MABA equals to A over MBBB equals to B. So you substitute the figure accordingly. So as always, when you substitute as exactly given to you in the questions. Okay. So if the questions use volume 25.00, you substitute 25.00. If the concentration use 0.200, you substitute at 0.200. Okay, so at the end of the day, you press your calculator, your concentration of the acid in here is actually 0.18. So in here, it can be 2 and 3 significant figure, but because this is a round number, so you just straight away give the round number, which is 0.18 mole per decimeter cube. Then we go for number 3. Given the pH of the ascorbic acid for sample apple juice is 3.80, so 3.80 is 3 significant figure, yeah? So number 1, calculate the concentration of the hydrogen ion in the apple juice, okay? So you have to use pH is equals to negative log of H plus, or H plus is equals to empty log of 10 power of negative 3.8. So you get your concentration of acid is 1.58 times 10 power of negative 4 in 3 significant figure. Then you use the answer. Use your answer in B1, B2, and C1 to calculate the dissociation constant of the acid. So in B1, you have concentration C, and C1, you have concentration of hydrogen ion. So Ka is equals to square root of H plus squared over C. So you have, no, there's no square root. Sorry for that. There are supposed to be no square root, so pardon me for that. So straight away use H plus square over C. So you get 1.37 times 10 power, 1.39 times power negative 7. So pardon me, there should be no square root in here. Okay. Okay, so that will be how you solve question number 1. Then we go to question number 2. An aqueous solution containing X2 plus form a white precipitate when an aqueous solution of sodium sulfate is added to it. So the solubility of the white precipitate is 2.33 times 10 power negative 3 gram per decimeter cube, and the solubility product is 1.00 times 10 power negative 10 mole square dm minus 6. So in here, if you notice carefully, all of them are in 3 significant figure. So you have to be careful with the answer given later. Okay, so calculate the relative formula mass of the precipitate. So in here, you given to you solubility of the precipitate is 2.33 gram times 10 power negative 3 gram per decimeter cube. So KSP is X2 plus times SO4 2 minus, you get 1.00 times 10 power negative 10. So it's X squared. So therefore, X squared is equals to 1.00 times 10 power negative 10. So X is equals to 1.0 times 10 power negative 5. And then you use the solubility to divide with the solubility of the precipitate. Okay, so you get the mass in here. So mass of 1.0 times 10 power negative 5 is 2.33 times 10 power negative 3. Therefore, this will make the relative molecular mass of XSO4 is equals to 2.33 times 10 power negative 3 divided by 1 times 10 power negative 5, which is 233. B. Calculate the relative atomic mass of X and name the white precipitate. So eventually you get your X is equal, you get your X first is 137. So check the periodic table. 137 is barium. So the precipitate is barium sulfate. And because the question said name the white precipitate, so you have to write out the name of barium sulfate, right, in this case. Okay. Okay, so and then C, write the equation to express the solubility precipitate name in B1. So you have BaSO4 give Ba2 plus SO4 2 minus. In this case, state of matter is important. You have to write out the state of matter for this. Okay. Okay, so with that, that is for number 2. Then we go to number 3. Table below give the data of a certain cola drinks. So you have cola, you have flavor extracted, cola nut extract, acid added is phosphoric acid, concentration of acid in drink is 0.49 gram per decimeter cube. The volume of the carbon dioxide in centimeter cube for drink is 1.12 centimeter cube, if I'm not mistaken. Huh? Okay, okay, 1.12 decimeter cube. Yeah. So number 1A, what is the concentration for the phosphoric acid in the cold drink? So you use molecular mass, you use the mass line, yeah. So RMM is 98. So concentration is 0.49 divided by 98 divided by 1.0 gram per decimeter cube, mole per decimeter cube. So you get 0.005 mole. Okay. And then B, calculate the pH of the cola drink given that the phosphoric acid is a strong monoprotic acid. So it ionized to give a single H plus in this case. So you use H3O, H plus is equals to H3O PO3 minus with 0.05 because the question already stated that it is a strong acid. So pH is equals to negative log 0.05, you get 2.3. Let's see, calculate the number of molecules of carbon dioxide dissociate in 1.0 gram of cola drinks. So in here, you first calculate the mole of the carbon dioxide dissolved, where you get 1.2 divided by 22.4, you get 0.054 mole. So number of carbon dioxide molecules, 0.054 multiplied by 6.02 times 10 power of 23. So that is how you calculate the number of particles, which is 3.23 times 10 power of 22 molecule of CO2. Okay. Okay, so with that, that is for number 3. Then we go to number 4. Compound cyanidine, CY, is responsible for the color of blackberry. Cyanidine exists as CBH, red color, at low pH, and CY, which is purple color, at high pH. So according to the equation, CBH plus dissociate becomes CY and H plus. So A, write the expression for the acid dissociation constant of Ka in this case. So Ka is equals to Cy times H3O plus over CYH plus here. So you have to be very careful with the equations used in here. And then B, the ratio of the red to purple is 1 to 5 in a buffer solution of pH 5.0. So what is the value of the dissociation constant in here? So the question already gives you the ratio as the red to the purple is 1 to 5. That means in here you log 1 to 5. Right? So 5.00 equals to pKa minus log 1 to 5. So you get your Ka is equals to 5.0 times 10 power negative 5 mole per decimeter cube. Okay. You get 2.5 and then you have to empty log. Okay, you get so you have the negative log to get your answer here. Okay. Okay, and then C, what is the ratio of the red to purple formed in the fruit juice buffer at 3.00? What is the color of this fruit juice? So you use the 3.00 equals to 4.3, which is the dissociation constant of acid, minus log CYH plus over CY. So you get the ratio of the CYH plus to CY is 20 to 1. So the color of the juice at pH 3 is red in color, okay? Because now you have more acid to the conjugate base, okay? Okay, and finally, 20 centimeter cube of 0.1 hydrochloric acid was pipetted to a conical flask and titrated with 0.1 ammonia. On the axis below, sketch a curve that we expect to for the above titration and label the endpoint. So you're expected to sketch and then label the endpoints in here. So this is the result of the sketch. So you just simply sketch. But the most important point is because this is a strong acid weak base titration, so you're expected to have a pH range below than 7. Okay, you have to have the endpoint below than 7 here. Okay, so this is just an example of diagram. As long as your neutral point in here is at acidic range, then this graph is accepted as your answer. Okay, and then B, the value of pKa for 4 organic acid are given below. Arrange 4 organic acid in a decreasing acidity and explain your reasoning. So the order is CCl3COH followed by CHCl2 followed by CH2Cl and finally CH3COH. In here, no need explain because 1 mark only. Okay. Number 2, calculate the pH of the solution that is prepared by mixing equal volume of 0.1 ethanoate acid and 0.1 sodium ethanoate. So this is the buffer solution. You have to use the buffer solution equation. pH is equals to 4.74 minus log 0.1 times 0.1. So you get pH equals to 4.74. Then number 3, describe the change in pH and composition of the mixture when a small amount of dilute hydrochloric acid is added. So since the solution in here is the buffer solution, so the pH does not change much. Okay. Okay, so with that, that is all the discussion for the structure question that I can have for you. So hope you enjoy my video and slightly learn a bit of how to answer the structure questions. So I see you all in our next video, okay? So see you all, bye.